We finished the univariate summary. We've looked at the whole group and described the average age, the standard deviation, the average, the standard deviation, and the sample size. But what we really want to do is look for relationships between variables. Our other variable is gender. So we would be able to ask this data, is there a difference in the age at which men and women win this award? What's your inclination? Do you think that do you think it'll be the same age, or if one would be younger and the other would be older? So to answer that question, let's start by organizing the data into two groups by gender and then create two histograms. Let me scroll back over to where our data is. So we want to sort by column C and then look at those two groups separately. Do you remember in Excel where if you had column C highlighted and then chose to sort, that you risked ruining your data because it would sort that column independently of the others? Google Docs is different in this case. In fact, you have to select just that column in order to indicate what you want Google Docs to sort by. So we're going to, under the data pull down menu, it's saying sort the entire sheet by column C. And then it's saying, do you want it alphabetically or reverse alphabetically? So let's choose that. And do you see what happened over here? Our summary table has gone kind of haywire because it really has sorted the entire sheet as if the summary table was connected to those records. It's a good job we had the label all on there. Oh, and look, our header row has ended up right in the middle here because it's now A, B, C, D, E, F, G alphabetically. Let's undo that. I'm just going to use Command Z to undo that sort. It's still possible to make that same mistake that you can make in Excel. So if I clicked on column C and chose sort the range by column C, it's going to sort my genders independently of the names and the films and the date of births. Something tells me that George would not be happy to be reassigned to a female gender. So let's go ahead and undo that as well. So we've tried two ways and we're not particularly happy yet. Let me show you two more ways that will make you very happy. So in this case, first off, let's see if we can address the issue of not sorting our summary table. So I'm going to select the range A through H, and I'm going to come under data, sort the range. I don't want to sort it by column A though. Do you see what my other option is? Oh, I can come down here to sort range ... That ellipsis means that it's going to open up open up a dialog box. It's going to give us more options. Sort this range. My data has a header row. I'm going to select that. And then I'm going to sort by and choose the header row gender. And here, look, I could add another column to sort by. And I'm just going to choose sort. So that fixed a number of things. Our header row is still at the top. It looks like our females are female and our males are male. That's a relief. And it's left the summary table over here alone. So that's one way that we've done it that it looks like it's giving us exactly the information we want. Let me show you another way. If I click on the number 1 and select that whole first row, under the data pull down menu, I can choose this feature filter. And so this is setting up to be able to filter and sort by each of these columns. So what did it do? First off, I can see that it has added little pull-down menus, little arrows on every column. When I click on them, I can see that it's allowing me to sort. It would allow me to filter. So if I sort, then that has sorted those nicely, but it has also sorted our summary table. Let me undo that. Let's select the range and then just go back to sort this range by gender. Let's create 2 histograms. 1 histogram for the actresses, 1 histogram for the actors. So to select the data that we want to include for the actresses, we're going to click and drag down all of the ages of the females. There we go. So we have that data selected. We're going to insert a chart. Excel's recognizing that this is a histogram. Where has it put it? Oh, all the way at the top. All right. Let's do some editing before we forget what this is. I've come to the top right corner, click Advanced Edit. Are these the actors or the actresses? Oh, I think these are the actresses, aren't they? So I'm going to call it Best Actress. I'm going to say that we don't need any legend. Boy, look at the bucket sizes that it has chosen. 19.5 to 26, 26 to 32.5. That seems very awkward. I think we're going to set it back to 5 so that we can easily compare it to the other 2 histograms. The title here, this is the horizontal axis. So this is going to be age at award in years. And remember the number format, we don't need those decimal places. So let's say that that's custom and that takes away those decimal places. We need to format the vertical axis, give it the title frequency. Make sure that it's got a 0 baseline, it does. When you're happy with the formatting, go ahead and update that. You know what we haven't got here? We haven't got a count of how many actresses there are. How many are in this data set? Let's go ahead and figure that out right now. I'm going to come back to my summary table that I'm creating here. Let me just clear out the prompts that I had for you there. We want to count if column C equals female. Remember count if we used in Excel. Let's see if Google has a similar one. I'm going to come under Insert Function. I can see count, but I want count if. Let's click on More and see if it pops up a list of all of them. Okay, so it's popped up a list of all of the functions in the Google Docs, but it's kind of done it in a bit of a funny way, hasn't it? Where it's taken us to another web page, and it's more of a help than a builder. So we want count if, and it's not going to insert it for us, but it's going to tell us you use COUNTIF, and then you specify the range, you open paren, specify the range, comma, specify the criteria, close paren. Okay, let's see if we can do it on our own. So I'm in cell N4. I'm going to type equals count if range, comma, criteria. I wonder if we need the quotation marks. I think we do. If you see right here, it's giving me the preview of what the answer is. And so it's saying that that would be 88. So it was the same function, the same formatting as Excel used. But you just have to remember it. It wasn't giving you that little dialog box to walk you through it. Let's go ahead and put that into our title. In this case, we're going to use the lowercase n because it's a subgroup, n equals 88. Let's create that histogram for the best actors. I'm going to scroll down until I start seeing the males. I'm going to click and drag and highlight to select all of the ages for the men. I'm going to insert a chart, and it's choosing the histogram. Now, up till now, I've been clicking insert from here, but I can just come along to customization, and that's the same as clicking that little down arrow. That's not a good label. How about best actors? We haven't done the count yet. I'll leave that for a minute. We don't want the legend. Bucket size. In order to really compare these two histograms, we're going to need them to be on the same scale and using the same bucket size. So let me type in the number 5 because that's the bucket size that we used for the females. The title here is Age at Award in Years. We don't need those decimal places. And on the vertical axis, we want the title to be frequency. Let's insert that and see how it looks. So here's our best actors. Oh, they put it sort of at the beginning of that group of data. Let's move it up so that we can compare it. I'm just single clicking and then clicking and dragging. Let me shrink those down. Oh no, let me just move them over. Let's see if I can get them on the screen. I think I'm gonna need to shrink them down. I'm holding down the Shift key so that they stay in the same aspect ratio. All right. My goodness, are they both on the screen? So let's use some of our visual reasoning skills and take a look at these two distributions. These are both true, accurate representations of our data, yet they are really misleading when we try to compare them. There are two, well, the reason that they're misleading is that both the x-axis and the y-axis are on different scales. And so our eyes are tempted to visually compare those two groups, whereas really that's the 25 to 30-year-olds and that's the 20 to 25-year-olds. We should be comparing the best actors at 25 to 30 to the best actresses at 25 to 30. We need those in the same place along the graph. In addition, the y-axis is at a different scale. And so where this, the number of actresses between 25 and 30 visually looks the same as the number of actors between 35 and 40, but that's not the same because it's not on the same scale. So let's adjust the scales on each of those histograms so that we can more easily compare those two. We need to adjust the x-axis, we need to choose the minimum and maximum that fits them both. It looks like 20 to 85. So it looks like we're not going to need to adjust the best actress, but we will need to adjust the best actor. Let's come under Advanced Edit and say that we're going to set the minimum of the horizontal axis to be 20 and the maximum to be 85. So we fixed the x-axis. Now we need to fix the y-axis. What scale would make sense? You want to use nice natural breaks. So 5s, 10s, 15s, or 2, 4, 6. Not, what have we got here? We've got 6, 12, 18, and we've got 7.5, 15, 22.5. Neither of those are particularly nice scales. Our scale needs to go from 0 to maybe somewhere around 25. Let's see how that looks. I'm advanced editing. The vertical axis. I'm going to make sure that it remembers to stay with a minimum of 0. And let's try a maximum of 25. Oh, I guess 25 is right there, isn't it? That's all right. And then let's do the same for the best actors. Scrolling down, our vertical axis. We want it to be from a minimum of 0 to a maximum of 25. So now we can compare apples to apples. The height of the columns mean the same. We can also compare apples to apples. The position of the columns means the same. Let's see if I can get rid of that zigzagging by just giving it a little bit more room. No, it's not doing that. I don't like the way the x-axis is labeling like that. So give it enough room and it will automatically adjust. There's one more piece of information that we need. We need to know the number of best actors. I'm going to add that to my summary table here. It's awfully similar to that formula, isn't it? I want count if column C is male. So let me use fill to fill that down. And then I've single clicked into where I want the males to be counted. I'm going to come up into the formula bar and delete the letters FE. Okay, so it's 88, that's not a surprise. And let's go ahead and add that to the title, n equals 88. I notice that the I and the pencil here are view mode or edit mode. I was having trouble making that little pop-up menu go away. And if you choose the view mode, then it does. When you're happy with your histograms, go ahead and click on the top right little downward arrow and choose Save Image. That will export them. save them in your downloads folder, and then bring them into your Word document and interpret this. Write a few sentences about the distributions of age in the actors and the distribution of age for the actresses. To finish up summarizing these two groups, we need to calculate those same descriptive statistics. We need to fill in the rest of that summary table. We've already done the counts. Let's go ahead and calculate the average and the standard deviation. We have the data sorted by gender still. And so in cell L4 here, I want the average of these ages. I think I'm just going to do it this way. I'm going to type equals average. As I start typing it, it fills it in for me. And I'm going to select by clicking and dragging down over all of the females. There it is. And enter to select, to accept that. So that's the average of those data points. I'm now going to do the same for the standard deviation. As I start typing, it pops up. So I want the standard deviation of this group of data. Right to there. All right. Why don't you go ahead and calculate the average and the standard deviation for the men? Did you come up with these same numbers? Let's have a look at the formula. So this is average H2 to H89, standard deviation H2 to H89, average H90 to H177, standard deviation H90 to H177. I'm just going to remove some of the decimal points on those standard deviations. Do these ages look the same? Does it look like men and women win this award at the same age? I would say just by looking at it, that it seems like women tend to win this award younger than men. We can see that both in this histogram and also in the averages. We're going to talk more about how we actually make that decision when we know that that is a true statement. But for right now, just looking at it, it looks like the women win the award under age 37 on average, and for the men, they're around age 45 when they win the award. At this point, if we want to present the comparison of these two groups' average age, well, my goodness, we'd create a bar chart, wouldn't we? A column chart. So let's highlight the data labels and the data and choose Insert Chart. Wow, Google's made a really bad suggestion there. Do you see what they're suggesting? They're saying, is this percentages? No, this is not percentages. This is ages. We're going to want that bar chart. Click on that customization tab and let's edit our options. First off, we're going to need a title. We always consider outcome by predictor. In this case, our outcome is age at award by our predictor variable is gender. Age at award by gender. Do we need a legend? No, it's not giving us any information at all. What's our horizontal axis title? That's going to go down here. That's our predictor variable, gender. What's our left axis, our vertical axis? That's our outcome variable, average age at award. Remember to use the word average in there. We've calculated an average. What scale do we want this on? Right now, Google Docs has chosen a really tiny scale. We're looking at a 10-year difference. And so it's as if we have zoomed right in and are exaggerating the difference between the average ages. It's true, it's accurate, but it's also misleading. We're going to want a different scale here. Let's look at the extreme opposite, the other way. If we say we're going to put it on a scale from 0 to 100, now we've zoomed way out and we're really minimizing the difference between those. A good rule of thumb, you want your data to take up the middle 2/3. And so here it's taking up less than half. So we could drop that maximum quite a lot. So is our data taking up about 2/3 of the table? Let's see. There's 1, 2, 3, 4, 5, 6 slices, and it's taking up just over 4 of them. That looks like a pretty good scale. We don't have to include 0. If we were looking at something charted in the thousands or the millions, we certainly wouldn't want to include 0. In this case, I think it's a good idea to include 0. I think this is a good scale. But this is part of the art of data visualization. The choice is yours. Let's look at some more options. We've got grid lines this time. So our grid lines are here. They're at nice, normal, every tens. But we have these decimal places. Remember, we got rid of those by choosing custom. When you're happy with your chart, go ahead and choose to update that. At this point, I'd usually encourage you to write it up. I'd encourage you to take that chart, download it, add it to your Word document, and write a few words, a few sentences that describe the pattern. I'm not sure that it really adds that much to our understanding. It's a very simple chart, and I think that in some ways, just using the numbers will be just as informative. So why don't you make up your mind whether you're going to use that chart or whether you're going to just use the averages and add a few sentences to your narrative that describes the descriptive statistics for these two groups. When you do include column charts of averages, you often see little I-beams that extend symmetrically above and below the actual data that's being plotted. Those are the standard error of the mean. They're acknowledging that each sample would be slightly different and that the calculated means would fluctuate. We're not going to include those in this case because we've got the entire population. We know this is the actual average age of the entire population. We're not dealing with a sample. We will look at that in more detail in a future tutorial. There's one more mistake I want you to make so that we can learn from our mistakes. I want to remember what our descriptive statistics are. So we've got average age for females is about 36, average age for males is about 44, okay? What happens to that table if we come back to our data and say, oh, I want to arrange this once again by participant number. I had it sorted by gender, but now I'm going to sort it by chronologically again. So data, sort range, there is a header row, sort by number. Are you watching? Are you watching the averages? When we click sort, those are going to dynamically update. The average is updated, the graphs, the charts updated, the histograms updated, and they are now no longer accurate. So let's undo that. We've got it back to where it was. We're going to use paste special. So I'm going to select my summary table. I'm going to do Command C for copy, and under the Edit pull-down menu, Paste Special. Remember, we want to fix just the values. We want to no longer have this dynamically updating if we organize our data. So we're going to say paste the values. All right. Let's just check and make sure. When we come back to our data and choose sort range, has a header row, sort by number. Are you watching 38.8, 44.4? Sorry, 36.8, 44.4. Excellent. Did you see? They're no longer dynamically linked to the first 88 and the second 88. They are just the values.